Okay, so this is section 2, question number 8, and we are asked to solve the pair of simultaneous equations. So we are given y squared positive 2y positive 11 is equal to x, and then you are given x is equal to 5 negative 3y. Okay, so what I'm going to do is I'm going to take this as 1 and this as 2. So equating 1 with 2, we get, in place of x I'm going to be substituting this value 5 negative 3y. So this is y squared positive 2y positive 11 is equal to 5 negative 3y. Move all the quantities to the left, so you have y squared positive 2y positive 11 negative 5 positive 3y is equal to 0. Add 2y with 3y, so you get y squared positive 5y, and 11 added with negative 5 would give you 6 is equal to 0, right? Now you can use quadratic, so I'm going to use the formula. So clearly a is equal to 1, b is equal to 5, and c is equal to 6, and the formula will be negative b plus or minus root of b squared negative 4ac divided by 2 times of a. So this is negative 5 plus or minus, so this is 5 squared negative 4 times 8 times c is 6 divided by 2 times of a is 1. So this is negative 5 plus or minus 5 squared is 25 negative 24 divided by 2. So this is going to be negative 5 positive root of 25 negative 24 will give me 1. So I have two roots, so this is negative 4 over 2 which is equal to negative 2. So negative 5 negative 1 divided by 2 which is negative 6 over 2 is negative 3. So y is equal to negative 2 and y is equal to negative 3. So if y is equal to negative 2, you substitute it in 5 negative of 3 negative 2. So this is going to give me x is equal to 11, and also substitute y is equal to negative 3 in 5 negative 3 of negative 3. This is going to be equal to 5 positive 9 which is equal to 14. So therefore the coordinates are, when x is 11 y is negative 2, when x is 14 y is negative 3. Okay, so this is the solution for this for the question. Okay, this is the next question. We have to express 4x squared negative 8x negative 2 in the form of a times of x positive h the whole squared positive k, of x being equal to 4x squared negative 8x negative 2. I take 4 out, so that would give me x squared negative 2x, and this is written as it is. Now I would like to rewrite it as a perfect square, so this is going to be x negative 2 whole squared. If I square it, I will get x squared negative 4x, right, positive 4, but I just have a negative 2x there, but I'm getting negative 4x here. Okay, so we will have to suitably write or choose the squaring component here. So x negative 2 does not work because we are getting negative 4x. So what if I place 1 there? If I had to expand this, this is going to give me x squared negative 2x positive. So clearly I'm getting negative 2x which is present here. So this is the correct quantity that has to be expanded. So fair enough. And when I square the constant, I'm getting a plus 1, but there is a negative 1 we need to, or I would say a negative 2 has to be catered to. So let me just complete the parenthesis. I am going to be getting an additional 4 out. So if I were to expand this, let me use the space here. This is going to be 4 times of x squared negative 2x positive 1. So you expand this, you get 4x squared negative 8x positive 4. So the first term is there, second term is there. But we need to get negative 2. But we are not getting negative 2, we are getting a positive 4 here. So to get negative 2, I need to add a negative 6 there. So if we were to rewrite this, this is going to be 4 times of x negative 1 whole squared negative 6, which is of the form a times of x positive h the whole squared positive k, where I can rewrite the value for h. So h is equal to negative 1 and k is equal to negative 6 and a is equal to 4. So all these values are extracted if in case they are asking us to obtain this value. Okay, so that is the solution for this question. Let's move on. Now the next question wants us to find the minimum value of f of x. Now we know, what do we know? We know f of x is written as 4 times of x negative 1 whole squared negative 6. Now f of x is minimum if this entire term is equal to 0. So that means we need to have x to be equal to 1. In other words, x minus 1 is equal to 0, which will give x is equal to 1. So f of x achieves a minimum at x is equal to 1, but they want us to find the minimum value. So if entire component vanishes, the only value that is left is minus 6. So the minimum value in this case is negative 6. So that's what they want, so we can give that as the solution. Okay, next they are asking us to get the axis of symmetry. So axis of symmetry, we have 4x squared negative 8x negative 2. This is the functional value for f of x. Okay, that's exactly what we are given. Now the axis of symmetry has a formula. X is equal to negative b over 2 times a. Now from here, a is equal to 4, b is equal to negative 8. So if we were to substitute the value of negative, or I would say b, this is going to be negative of negative 8 divided by 2 times of a is 4, which is positive 8 divided by 8. So you get 1. So x is equal to 1 is the axis of symmetry. Of course, I have already obtained the axis of symmetry when I explained to you how to get the minimum value for the function. Okay, but this is more of a methodic manner. So to get the axis of symmetry and then get the value for x. So this is the axis of symmetry. Now if you were to substitute, say we have 4x squared negative 8x negative 2, right? So if we put x is equal to 1 here, you will get 4 times of 1 squared negative 8 times of 1 negative 2, which is equal to 4 negative 8 negative 2. You add this, you get negative 4 negative 2, which is nothing but negative 6. So this is one way to get the minimum value of f of x. Okay, you can also get the minimum value in this fashion. Now this is the next question. We've been given a graph which is actually the acceleration of a car. So let me draw that. Okay, so this is given as 12 units. This is speed, meters per second. This is O, this is 16 32, 40. This is stage 3. This is stage 2. And this is stage 1. So the figure shows the 3 stages of a car's journey. Okay, so we are asked to find the acceleration of the car for each stage. Now we are not actually required to find the acceleration for all the stages. They just want us to get the acceleration for stage 2 and stage 3. Now go back to the figure and you check. For stage 2, you see we have a horizontal line. So this means the slope of the line is equal to 0. So this in turn means the acceleration is going to be 0 meters per second squared. Okay, so that is the solution for stage 2. And probably I will write this as 0 meters per second squared. Okay, so now for stage 3, see this coordinate is 40, 0. This coordinate is 32, 12. Okay, so we will have to find the slope with the coordinates being 32, 12 and 40, 0. So this is x1, y1, x2, y2. M is equal to y2 negative y1 divided by x2 negative x1. So 0 negative 12 divided by 40 negative 32, which is nothing but negative 12 divided by negative 8. Oh, this is positive 8. So 4 divides here, 3 times 4 divides here 2 times. So it's negative 3 over 2 meters per second squared. So I'll write it like this. Okay, meters per second squared. So that means the car is actually decelerating. Okay, so this means slowing down. And what is the rate? The rate is 3. You don't need I need to write negative sign there because we are already mentioned it as deceleration. So slowing down rate of 3 over 2 meters per second squared. Now this is